Hi, in this video, I'm going to talk about how to architect and implement using AWS Cloud. The agenda is going to be, we're going to start with today's cloud environment, have a look at the cloud infrastructure that AWS has built, have a brief overview about its various services, about 130 plus, and then move on to the various services that are going to be part of this course. Finally, we'll have a look at who is using AWS and end it with benefits of learning this skill. Today, none of the Fortune companies are stuck with any one solution. Almost all of them have embraced hybrid cloud, where they have their on-premises data center, they have their private cloud, and they have embraced one or more of the public cloud. Now, talking about AWS, as you can see in this diagram, it has established data centers across 24 regions, more than 76 availability zones, and counting. It has got about 130 plus services, which include the infrastructure area, platform as a service, and software as a service. The compute, network, storage, etc. constitute the core infrastructure services, whereas all your application services, your analytic and management tools, databases, mobile services, etc., they fall under the PaaS and SaaS categories. Now, let's move on to what this particular course is going to cover. To start with, when you want to establish something on the AWS, first is you design and define the contours, which is called your private cloud. AWS calls it the virtual private cloud. Yes, that's what we'll end up creating the moment we create an account with AWS. As you can see, the moment you create this private cloud, built into it is a router. We'll shortly discuss its functionality. And once we have designed and defined this contour, the next step is that we're going to define the networks that we want. Some of the networks may host servers that are internet facing. Users from the internet may be accessing those, and they're called the public subnet. And others are going to host servers which are totally for internal access and use. Now, the diagram would be self-revealing as to why a router is required. Obviously, to interconnect the different networks that we have built. And then we deploy the virtual machines on each of the subnets. Let me assume that I'm going to put up a web service or an e-commerce portal on the public subnet for internet users to access, and I'm going to have my internal servers, databases, etc. on my private subnet. Now, the virtual machines are not called virtual machines by AWS. They are called Elastic Compute Cloud or EC2 instances. Okay. How do we provide internet access? Or rather, how do you ensure that the users on internet are able to access the web server? And that purpose is served by the Internet Gateway. Right. What about the servers in the private subnet? They need to download something from the internet. They need internet access. Well, internet users must not access the private subnet machines, but the private subnet virtual machines must be able to access the internet. And for that purpose, you have what is called as the NAT Gateway. All right. I have an on-premises data center and I would like to connect to the AWS Cloud. I might connect either using a leased line, which I call the AWS Direct Connect, or I may use any other connectivity and implement a VPN. Then the VPN gateway on the AWS Cloud connects to the customer gateway on the premises data center. So as you can see, all these components constitute the network part of AWS. What about security? Security is implemented at two levels. One, at the instance level. So we enable a firewall equivalent called the security group, which permits or denies access to this EC2 instance. What services are allowed, not allowed is defined in the security group. As you can see, at every instance level, you have a security group configured. And when you want to restrict traffic to and from a network, you have what is called as a network access control list. So between the network access control list and the security group, access to networks and individual servers are controlled. Okay. Now what happens if I have more load? I don't have just one server, but I have multiple servers serving the same purpose to cater to increased load. I bring in another component, the load balancer, elastic load balancer. So anytime the internet users are trying to access my e-commerce portal, it actually hits the elastic load balancer, which would divert the request to either of the web servers. So the algorithm of how it diverts, how it detects the health of these servers is built into the load balancer, and it handles both redundancy as well as increased load. Now, suppose I'm not able to predict the load. The load is dynamically changing. There are offers running through a certain period during which load is high, and when there are no offers, the traffic is normal. So what I can do is I can have what is called an AutoScaling Group configured. What does this do? It dynamically increases the number of servers whenever load is high and dynamically decreases when load gets back to normalcy. We will see how that works. Coming to the different storages that we're going to deal with, we need to understand that there are going to be some storages which are local to the virtual machines or the EC2 instances, much similar to the local hard disk of a desktop or a laptop. That's referred to as elastic block storage. And for Linux instances, if you want a shared storage much similar to your network attached storage or NAS, you have an equivalent called the EFS, the Elastic File System, which can be configured as a shared storage to different Linux servers. And the most popular of the lot is your simple storage service S3, which is more often called the object storage. This has got multiple functionalities, not just storage. It also acts as a backup snapshotting destination. It can also function as a static website, and there are quite a number of features that are supported in this type of storage. So in all, this course would cover the S3, EFS, EBS, and related topics snapshot. Of course, the newer FSX will also be covered. Okay. So let's assume there's an environment where the number of servers I have is not just in one location but multiple locations. You might have heard of these terms GDPR. So data cannot leave the European Union. So what I do, I have a setup in the European Union region, probably in Ireland. I have a setup, let's say in Mumbai, for other parts of the world. So whenever users from European Union access, I would like the traffic to be forwarded, all recordings of data done in the Ireland infrastructure. For rest of the world, they can use the Mumbai location. So here is where I have another component for diverting traffic to the appropriate location as desired. That's called Route 53. If you have guessed, then you're right. It is the DNS with advanced feature set built into AWS. The Route 53 helps with DNS functionality, helps register domains, and also helps manage traffic at this level. So you can see in this case how we approach the entire scenario. Supposing the AutoScaling group, whenever it increases or decreases the servers in the group, we would like to be notified. I can configure yet another service, the simple notification service, to send a message to the administrators. It could be by way of email or SMS. Of course, there are a few more functions supported, but in this diagram, we can think of sending an email or SMS to the administrator whenever the number of servers increase or decrease automatically. Configurable. Okay. Let's look at another scenario. I have set up a multi-tiered application which has got web servers, application servers, and database as part of the same e-commerce portal. We might come across different types of databases. Those who are from the database background would know there is this relational database and there is the NoSQL database. AWS supports both of them. Relational Database Services, or RDS, supports most of the popular RDBMS, and the NoSQL like MongoDB and others are also supported. We would see how to spin up a database inside the AWS. It is highly automated and simple. It does not involve the tedious procedures which is done typically manually. Coming to monitoring of information, the built-in tool is called CloudWatch. I can enable live monitoring. I might be able to capture alarms if configured. I can log all the details in CloudWatch. It doesn't stop there. Suppose I wanted CloudWatch to also set an alert or raise a trigger whenever you want to take a backup of the database. It could be the alarm driven, or it could be a rule to specify that backups need be taken periodically, whatever it is. Yes, CloudWatch comes in. Let me say I set a trigger to take backups. In this case, it's called Snapshot, once in an hour or two. So what I do, this guy raises a trigger and sends it across on a queue. AWS has a queue management system, the simple queue service, where the trigger goes, and this trigger in turn kicks off a snapshotting process. Now here is where it gets even more interesting. You have a serverless component in AWS, the Lambda function. What you do is feed in a code here and the Lambda executes it for you. You do not need a server for execution. So the moment CloudWatch sends a trigger, through the SQS function, the snapshotting function is enabled in Lambda. So the Lambda executes that particular code and initiates a backup or snapshot. So can you see how the cycle closes? This is the kind of case study which we will take up to understand how real-time functionality happens. And what about security? Yes, there is the identity and access management section where it allows you to configure users. Users may be admin users or programmers wanting programmatic access. It helps us configure multi-factor authentication, authorization as to what they can do, what they cannot do. All these are configurable in the IAM section. What about security? Yes, you have a lot of encryption which is enabled with built-in key management systems. You want to store data, you want to encrypt it, yes, that can be possible. The key management system, or KMS as it's called, is a built-in feature of AWS. You would be able to store data and secure it by encryption. It could be in flight or at rest. Both are supported. When it comes to compliances, yes, you can check the artifacts. All the compliances are typically supported by most or all of the public cloud. Finally, what are the other services? The content delivery network, which is the CloudFront, helps cache any content, any web content across the globe. AWS has set up an elaborate caching network across the globe. Let me say that I have my website or portal hosted in Mumbai, one location, and it is being accessed by users across the world. Users in far off places have started complaining that the performance is low. They are not able to access. There is a delay in accessing the various pages of the portal. So what I do? I subscribe to the CloudFront feature of AWS. It immediately caches my web server content in its edge locations spread across the globe. Subsequently, the users get all the content locally from the closest place, thereby tremendously improving the web server performance. That is the advantage of CloudFront. It also supports the simple workflow service where I am able to set a list of tasks to be performed one after another. Let's say I've got 4 or 5 different independent tasks to be performed one after another. Task 1 completes, then it has to move to task 2, then to task 3, all built into AWS or even on premises. Then I can make use of the simple workflow service of AWS to get it executed. Finally, I'd like to automate all the stuff. I'd like to build a web-based application. I'd like to build a web-based WordPress site. Yes. Totally automatically, if it has to be done, I can take the help of Elastic Beanstalk or CloudFormation. So all of these services would help perform various tasks, and today, if the startup community is rising so comfortably thanks to public cloud like AWS. So these are the vital services that would be covered as part of this course. Even though I have not exhausted all the services, this constitutes the major services that would be discussed. And let's have a look at who is using AWS. Some of the popular names: Netflix, Dropbox, Nasdaq, Airbnb, Shell, GE, 3M. You can see that they use different services of AWS. This is just a glimpse of it. It is not exhaustive. So, why should you learn this? I think you have an answer. Why should you learn it from us, RJP? Yes. We have the experienced faculty with over decades of experience who teaches the subject. We focus on conceptual understanding, combine it with use cases and case studies to design the lab tasks. We give you assignments which are not discussed in the class for you to think, find out solutions, and implement things yourself. So it's not just about doing hands-on during the classes. The assignments help you go beyond, makes you apply to real-time situations. And if you're going to take a practice test, that would help you score better in the certification exams. And this program is suitable for those who are aiming for the solutions architect or the SysOps track at the associate level of AWS certifications. If you find it useful, interesting, you're most welcome to join our course. Hope to see you there.